Okay, so I guess we can start. So the first problem is on the board. I'll give you like 2 minutes to try to do it. Okay, so it's been about 2 minutes, so I'm gonna start explaining it. So we have real numbers a, b, c, and d such that -20 is the root of x cubed plus ax plus b, and -21 is the root of x cubed plus cx squared plus d. These two polynomials share a complex root m plus root ni, where m and n are positive integers and I is equal to the square root of -1. And we want to find m plus n. So first, since -20 is a root of x cubed plus ax plus b, then that means okay, plus b is equal to x plus 20 times some other polynomial. And then similarly, x cubed plus c x squared plus d is equal to x plus 21 times some other polynomial, because -21 is the root of x cubed plus c x squared plus d. And then since they share the complex root m plus root ni, and the coefficients are all real and rational, then that means that we have to have the third root for the m minus root ni, because that's the conjugate of m plus root ni. So that means that the other quadratic for both of them should be the same. Okay, so we have x, so the quadratic with roots m plus root ni and m minus root ni would be x squared minus 2mx plus m squared plus n. The coefficient here should be roots, and the coefficient here should be the product of the roots. And then after that, we have this. We can plug that in here. So we have like that. And then so in the first one, we know that the coefficient of x squared should equal to 0, since the coefficient of x squared and x cubed plus ax plus b is 0. So then we have, and then the coefficient of x squared here would be, so for, you can either have x in -2mx for -2m x squared, or you can have 20 in x squared if you want a factor of x squared. So then this has to equal to 0, so then m is equal to 10. And then for the second one, the coefficient of x should equal to 0. So then that means that if we have, so we have x times m squared plus n to have a factor of x, and then 21 times negative 2mx for a factor of x. So we have something like that, and then we know that this must equal to 0. So now if we cancel the factor of x, then we have m squared plus n is equal to 42m. So then, and since we already found m is equal to 10, then 100 plus n should equal to, so that's equal to 320. So then now it's asking m plus n, so we can just add them, and it's 330. Okay, so the next question. So it's on the screen, you can do it. I'll give you 2 minutes. Okay, so it's been about 2 minutes, so I'm gonna start explaining it. So it says, in a Martian civilization, all logarithms whose bases are not specified are assumed to be base b for some fixed b greater than or equal to 2. A Martian student writes down 3 times the log of square root x times log of x is equal to 56, and log base log of x is 54, and finds that this system of equations has a singular real number solution x greater than 1, and we want to find b. So in order to simplify these logarithms, we can let x equal to b to the b to the a, and then that would be the square root of x should be b to the power of half of b to the a, and then log of x is just log of x should be log b of x, base b of x, so it's just b to the a, and then this is equal to 56, and then log of x is b to the a, and then x is just b to the a, and this is 54. So then now from the first one, since these two are both base b, then the log base b of this would just be the sum of b to the a over 2 and a. So then 3 times b to the a over 2 plus a is equal to 56. And then for the second equation, we can take out 1 over a from the a on the bottom. So we have 1 over a times log b of b to the a, and that's just b to the a. So then this is 54. And then now we can, since we have two equations in terms of b to the a and a, then we can let b to the a equal to some number x, and a is just a. And then, so then we have 3 times x over 2 plus a is 56, and we have x over a is equal to 54. And then from the second one, you can get x is equal to 54a, and if we replace, we get 3 times 28a is equal to 56, so then a is equal to 2 over 3. And then since x is 54a, that means that x must equal to 2/3 times 54, which is equal to 36. And then if x is 2 should equal to 36, and that means that b is equal to 216. And then it's asking for b, so the answer is 216. So the next problem's on the board. I'll give you 2 minutes to solve it. Okay, so it's been about 2 minutes, so I'm gonna start explaining the problem. So we have a regular octagon Caroline with CA is equal to RO is equal to LI, which is equal to NE, which is root 2, and AR is OL is IN is EC, which is 1. The self-intersecting octagon Cornelia encloses 6 non-overlapping triangular regions, and then let K be the area enclosed by Cornelia, and that is the total area of the 6 triangular regions, and we want to find K. So we have a rectangular octagon. So we have CAROLINE. So it's a quangular. So if we extend these, so since it's a quangular, then each of these angles is 45. So then that means that if CA is root 2, then each of these is 1. And then CE we know is 1. So it's like that. And then Caroline would be CA. No, Cornelia. So it's just it's the area triangular regions. So in order to find the area of these 6 triangular regions, we need to do similar triangles. So if we have, since it's like symmetric across the midline, then that means that the point here has to be equidistant from these 2 lines. So then the height here is half. So then if n is equal to 1, then that means that the base here has to be 1/3, since this height is 1 and this height is half, and half over 1 plus half is 1/3. So then the base here is 1/3. And then after that, to find the area of the smaller triangle, we just do half of half times 1/3, which is equal to 1/12. So each of the small triangles is 1/12. So then now we want a bigger triangle third, and the entire length would be 3, since like this is 1, this is 1. And since metric, then 3 minus 1. So these 2 distances are the same. And then since 3 minus 1/3 is 8/3, then both of these should be 4/3. Goes times 4/3. 4/3 times 1 equal to 2/3. So then now to find, do 2 times plus 4 times 2/3, and this is equal to 15. So the first part is 1/6 plus 8/3. So then this is just 5/2. And then so then it's just asking A plus B, so the answer would be 7. The next problem is on the board, and I'll give you Okay, so it's been about 2 minutes, so I'm gonna start. So a rational number written in base 8 is AB point CD, where all digits are non-zero. The same number in base 12 is BB point BA. And then we want to find the base 10 number ABC. So AB point CD in base 8 is the same as 8A plus B plus C over 8 plus B over C in base 10. And then BB point BA in base 12 is the same as 12B plus B over 12 plus A over 144. And then these two numbers are equal. So we need to solve this equation. And then we know each of these numbers A, B, C, and D are all between 0 and 7 inclusive, since they're all digits in base 8, or from 1 to 7, because they're all non-zero. So first, if we cancel B, and then if we can multiply by 64 times 9 on both sides to get rid of the fractions. So we have 8 times 64 times 9A plus plus 9D is equal to 12 times 64 times 9 times B, and then plus 64B. Okay, yeah. 48B, and then plus 4A. So we can cancel stuff. So if we have 8 times 64 times 9, and that's just that's 4608 A plus 72C plus 9D. That's equal to 108 times 6912 B plus 48 B plus 4A, and then 4604A plus 72C plus 9D is equal to 6960B. So in order to solve this, so if we do mod 3, then we realize that A must be a multiple of 3, since the other terms are all multiples of 3 except for 4604. So then that means that A has to be 3 or 6. And then after that, if we plug in 3, then we have 4604 times 3 plus 72C plus 9C is equal to 6960B. And then if we mod 9 for this, then that means that we have to have, so 4604 is 5 mod 9, so then it's 5 times 3 is equal to 3B mod 9, since 72 and 9 are both multiples of 9. So then that means that B must equal to 2, mod 3. So B can either be 2 or 5. And since they're all single digit numbers that are less than 8, then that means that it'll only make sense for B 2 in this case. So now if we do B is 2, then we have 4604 times 3. So you have 6960 times 2 minus 4604 times 3 is equal to 72C plus 9D. And then if we calculate 6960 times 2 minus 4604 times 3, then we get 108. So then that means that 72C plus 9D is equal to 108. So then 8C plus D is equal to 12. And then, so 3. And then since C and D are integers, then C is equal to 1 and D is equal to 4. And then that means that A, B, C is the answer.